Everybody, so short video today on what I hope will be a short topic. We're going to compare the properties of ionic and covalent compounds. We've talked a lot about how they work on their own, what they're like individually, but we haven't taken a lot of time to talk about how their properties differ, particularly on a macroscopic scale. We've talked about what their electrons are doing under a microscope, but if I gave you a substance in the wild and asked you if it was ionic or covalent, how would you figure that out? We're going to answer that question today by looking at some of the more large-scale properties of ionic and covalent compounds. But I figured a good place to start would be to review what we already know about ionic and covalent compounds. So to start with, I have made this Venn diagram of both of them, and we're going to go ahead and compare the two. We already know that in ionic compounds, electrons are transferred, and in covalent, they're shared. For ionic compounds, the electrons literally go from one atom to another and create charges on each atom. In covalent, we don't get those charges. They share their electrons and form a covalent molecule. We also know that for ionic compounds, they're made of a metal and a non-metal. If you look at examples here, sodium chloride, that's a metal and a non-metal. Potassium oxide, that's a metal and a non-metal. Strontium nitride, that's a metal and a non-metal. For covalent compounds, we know that they're made of two non-metals. So that's things like water, H2O, that's two nonmetals, hydrogen and oxygen. Ammonia, which is NH3, that's two nonmetals, nitrogen and hydrogen. And then for oxygen here, the good old stuff that we breathe to stay alive, it's just two nonmetal oxygen atoms linked together. So those are the things that we already know, but they make it kind of difficult to identify if something is actually ionic or covalent unless it's on paper. How do we do this when we've just got some substance put in front of us? If I just hand you some white powder, how do you know if it's salt or cocaine? Well, we have to look at the physical and chemical properties on a larger scale. So let's look at some of those to get some rules about identifying ionic and covalent compounds. So to start, we'll talk about conductivity, and to give you the best information up front, ionic compounds can conduct electricity, covalent compounds can't. What I mean by this is that if you took an ionic compound like salt and you dissolved it in water, you would get a solution that you can run a current through. But if you try that with, say, sugar, that solution wouldn't be able to conduct electricity. Even just pure water doesn't conduct electricity, and the reason why is because it's a covalent compound. It's made of hydrogen and oxygen, two nonmetals. But Mr. Cruz, I hear some of you shouting, doesn't water conduct electricity? I see it all the time in cartoons. Coyote's chasing Roadrunner, and he steps into a puddle that's got a wire in it, and it shocks him. Well, that's not really accurate. You know, water laying around on the ground has plenty of ionic stuff dissolved into it just from sitting in the dirt. But if you took actual clean distilled water and tried to run a current through it, you wouldn't get much electricity going through it at all. So now let's talk about our next characteristic, rigidity. Basically how easy it is to bend something. The information up front is that ionic is brittle, it doesn't like to bend. Covalent is flexible, it does. Ionic compounds are usually brittle because they form these rigid crystal structures. Think about salt. If you look real close, you'll see that it is actually a crystal shape. But covalent molecules tend not to form those crystals, so they're more flexible. Like, let me move my camera. Like rubber is a covalent compound, so it's very bendy. The long and short of it is covalent is bendy, ionic is breaky. So if you can remember that, you'll be in good shape. Now let's talk about melting point, and for this one, I brought in some info to kind of prove it to you. The thing to remember is that ionic compounds have high melting points and covalent have low. If I look at methane, for example, which is covalent, it melts at negative 182 degrees Celsius, meaning way below the freezing point of water. It boils at 161.5 degrees Celsius. So it's usually a gas at room temperature. It'll boil away. Compare that to sodium chloride, table salt. It doesn't melt until you get to 801 degrees Celsius. You could melt steel before you would melt salt. In fact, they sometimes use salt as crucibles in a furnace to melt metal, because it's just not going to melt. It boils at 1,465 degrees. So as you can see, the ionic stuff, same thing with sodium carbonate, is really high melting and boiling points. Whereas for covalent compounds, it's relatively low. Water boils at 100 degrees C. It melts at 0 degrees C. Sugar is 146, which seems high, but really you can do that on your stove. Same thing with iodine. It'll melt on your stove. Compare that to sodium chloride. You'd probably melt your pan before you melted salt on the stove. Then we'll talk about solubility. What is solubility? Basically, it means, can it dissolve in water? For ionic compounds, usually can. For covalent, usually doesn't. There are exceptions to this rule. Think sugar is a covalent compound and it still dissolves, but generally covalent compounds don't. Think about oil. It just floats on top of water. That's one you can do at home. You can take some table salt, it dissolves. Take some oil, you'll see it floating around on top. Then put an Alka-Seltzer tab in it. Wow. So yeah, like I said, pretty short, straightforward video. These are just a few of the characteristics that you gotta know about each of these, and it'll help you identify if something is ionic or covalent. There are experiments that you can set up to figure this out. Dissolving something in water, or melting it on the stove, or trying to break it. These will all tell you if something is ionic or covalent most of the time. So rather than our usual Google form this week, what I'd like you to do instead is draw this Venn diagram and then add to it the other characteristics of ionic and covalent compounds. Once you've done that, just take a picture of it and upload it onto the assignment. Thank you very much. Have a great day, guys.